Hey patrons, I am just barely getting a chance to get a new forecast done. I'm in the middle of shooting a formal forecast, but until then I thought I'd get a new informal forecast up for you all because there's so much going on and I just knew I wasn't going to get everything done in time. So my goodness, I am in the middle of trying to do finals. I'm in the middle of trying to get some new gear in the studio working. I'm actually doing a live rig show right now, unlisted on YouTube, and then I'm going to post it on Patreon. If it starts working, then oh my gosh, I might actually be able to give you more frequent forecasts informally for everyone on Patreon, which would be really, really great. So I'm kind of like a bit disheveled if I seem a little bit out of step. Just forgive me. I've got like a million things on my mind right now, and I'm just trying to get through them one by one. And of course the sun decides to fire a solar storm, an Earth-directed and a big Earth-directed solar storm, right when I'm trying to get through grading my finals. So I have no idea how well any of this is going to go, and how well I'm going to be able to watch the real-time unfolding of the solar storm that's going to be hitting hopefully tomorrow. So I've got right now, I'm looking at a stream feed. Oh my gosh. This should not be, uh-oh, is it live? This should not be live. Oh my gosh, but I see people in the chat right now. Holy merd. Okay. Hi. Big first blunder. Okay, great. I did not make this an unlisted thing, and I cannot read the chat right now because I did not expect this to be live publicly. Oh well, everybody gets a really neat view of what's supposed to be an unlisted trial. So if I look a little red right now, that's that's on me. I shouldn't. This was supposed to be a private Patreon forecast. So you guys get something special right now. We're working on some new technology that's going to do more. Anyway, okay. So I apologize. I do see a chat feed going now. Oh my gosh, I cannot see it from here. So you guys talk amongst yourselves and just enjoy the show. We do have a solar storm that is going to be hitting tomorrow, actually probably in less than 24 hours. And this was supposed to be a forecast just for my Patreon members so that they got to see, they got some new insight in what's going on. So you guys get to actually see what dirty laundry looks like, you know, when I do informal forecasts, because they are really this kind of crazy. I'm running it right off my PC, and I do a little green screen just like I do with my mini courses. So it's a lot more informal, though. It's a lot more casual than my formal forecasts. But I'll get right to it because I am going to post this on Patreon later for everyone. All right, so the sun has been busy. It has been firing off several, well, not quite M-class flares, and we'll get to that in just a second. But region 2790, it's about to fire off right now. There it goes right there. That was a near M-class flare. It did fire an Earth-directed solar storm that we're waiting for right now, and it's fast. Oh my gosh, I didn't even have time to prepare to be able to get anything really done for anyone. In an upcoming formal forecast, you might see some plots, but if you go to my Patreon website, and if you're a patron, you'll be able to get the formal, some of the formal figures that you'll see in this forecast that just talk about when the solar storm is going to hit. You can also see them on Twitter and on Facebook. At any rate, back just yesterday, the sun fired this gorgeous near M-class flare that launched a solar storm. It is a halo eruption. We'll talk about it in a second. This region has since kind of died down a bit. It's still popping a few things, but not very much. Don't think we're going to get much more from it. But this solar storm is coming. Now, the prediction models, I've looked at both NASA's and NOAA's, and they are a little out of sync, which is typical when you have a very fast solar storm coming. Because oftentimes with the scientist in the loop, it's really hard to tell how quickly something is moving and how fast it's going to plow through the solar wind. But we do have an additional surprise, which is that this solar storm is going to be dealing with this, or going to be coming on the hot on the heels of this coronal hole. We've got fast wind from this coronal hole that's going to be pushing through the Earth strike zone here. Literally, we're expecting at any time. And so this particular solar storm is actually going to be embedded to a great degree in the stream interface in front of that fast solar wind, which has a tendency to squish it a lot more. So if anyone is looking at some of the predictions on the NOAA website, SWPC's website, and they're wondering why are they predicting a G3 level solar storm, this is why. Is it because the solar storm just happened to be launched right, you can see it's almost in parallel with this, you know, at least longitudinally, it's almost in parallel with this, this coronal hole that's rotating through the Earth strike zone. So we're expecting both of them to hit nearly at the same time, and we'll see that's the major difference between the NASA model and the NOAA model. NASA has the stream interface and the CME, the solar storm, hitting nearly at the same time. NOAA has the solar storm trailing. And that will make a difference when it comes to impact and what types of effects we're going to expect to see from this particular solar storm. Now after that, we're still getting a few, like I said, a few pops here and there, but there's not a lot of activity on the Earth-facing disk, so we're not going to expect all that much. It's really going to be this big storm, and this thing could last easily 48 to 72 hours, just depending upon how it hits with that solar wind. If we take a look at the, we're going to take a look at seeds, and this is an automated prediction model. Or not product, sorry, I'm jumping ahead. An automated detection for, my goodness, now I've got a frog in my throat. An automated detection for halo or just any type of coronal mass ejection in coronagraphs. What you're looking at, you guys oftentimes see me put this up during, I'm sorry, I'm still laughing at this is public, I'm so sorry. This is what informal forecasts look like, folks. They're really messy. You see me oftentimes put this view up when I'm doing the formal forecast, when I want to show different types of halo signatures that come out. And yes, we have an amazing halo. On this side, you're looking at the raw image. That's the red image from the LASCO coronagraph. On this side, you're looking at the difference image. And that halo is massive. Look at that thing. You know, in my formal forecast, I would typically freeze it and draw a line all the way around the sun. And I'll see if I can do that. Let me back it up just a smidge. So you can see that this halo, okay, you can actually even see it. My goodness, this is nice. I hadn't had a chance to check this, but you can actually see it pretty well in the raw, in the intensity images, which means these things are getting more dense. These are no longer the wispy solar storms that we've been seeing through solar minimum. These are getting to be serious here. So this is nice. It's nice to see again. And in the difference images, which obviously enhances these features, you can see that ring all the way around the sun, okay? Now this is what we call an asymmetric halo because it's coming off to the, in this case, the southwest. So it's not a symmetric halo, but it's still a pretty decent ring all the way around. And that's definitely meaning that's going to be Earth directed. It definitely is coming toward us. And you can see when I set it in motion again how fast it is. This is the reason, whoops, it helps if I do it forward instead of backwards. Are you going to go forward for me now? Okay, good. But you can see that's a pretty fast halo, and that's one of the reasons why models, when we do prediction models, why they're not always the you know, like you see NASA's and NOAA's models are off. There's a lot more error when you have these fast solar storms leaping off the sun like this, because you can get a lot more error in terms of depending upon what type of analysis you do and how you do it, and what parts of that big solar storm you're looking at to gauge how fast it's coming. There's a lot more error in that. So that's why you're going to see about a 12-hour discrepancy between the two, between both NASA and NOAA. Now, as I continue to laugh at myself for doing this live instead of just for Patreon, at least you guys get to know what my Patreon folks get. This is, if you join my Patreon community, this is normally what they get. They get all this special stuff that you guys won't get. Sometimes they even get, I'll put on the sun, I'll put magnetic field lines and stuff like that, so they can actually see some of the real intricate details. These are the types of things that I don't typically do for my forecasts, because it's just too complex, it's just too much stuff, and I don't want to overwhelm people. But okay, so but now let's take a look at stereo. And if I do this faster, not quite that fast. You can see, I might get the heck out of the way. Let me stand on this side. You can see my cursor out of there. when it starts over. You can see region 2790 and 2791. Whoops, if I'm pointing in the right place. Here's 2790, here's 2791. You can tell 2790 fires off that solar storm. If I'm looking at the right one, I think it is. Yeah, boom, right there, okay. And I'm, of course, standing in the way of this really cool region back here. Now, when this resets, you'll see that this region here that has not rotated in Earth view yet, it also fires off what looks to be a pretty decent solar flare and maybe even coronal mass ejection. Where did it already fire it? It's going to reset and do it again. But it is being it looks like might be an active player. It might be an M flare player. It's kind of hard to tell. And also it's kind of hard to tell when they, you know, the more flares that they fire off, oftentimes they deplete themselves, so they end up not being nearly as exciting when they finally rotate into view. But this region will rotate into view in probably about 3 to 4 days. And so when we see that region rotate into view, it will boost the solar flux up a bit. The solar flux has been kind of dying down a little bit, but it'll be boosted back up by this region, guaranteed, because it looks like this region is pretty bright. And we'll see what happens afterwards. But we've definitely settled down just a little bit from where we were a few days ago in terms of solar flux. We are back down into the marginal range for radio propagation. So yeah, see, that region is pretty active. Yeah, we'll just see, okay? Now, if we switch to same thing, this is another coronagraph, but this is now coronagraph for stereo, okay? This is the stereo ahead coronagraph, and now as you can see, we're now looking at that same halo eruption. Really more to check for the north-south, let me stand out of the way, really more to check for the north-south, you know, asymmetry, to see, is this thing definitely going across the Earth-Sun line? Will it definitely be wide enough to hit Earth? And it definitely does look like it's wide enough, and as you can see, it's quite fast. So all of these coronagraph images, again, this is the difference image, and I'm standing in front of the, I should probably get out of the way, and let you see the actual raw intensity images, which are the red ones there. You actually can see, you know, this is a pretty large coronal mass ejection. And we should expect, I would think, at least a G2 from this. If obviously the solar wind, the magnetic field in the solar wind is pointed the right way. Sometimes these things can be aligned incorrectly, and they'll just be bumper cars, so you won't really get much out of it. Now, here was the, just to kind of give you something here. Here's our our X-ray flux right now, and you can see I'm gonna stand. Yeah, I'll stand over here for a minute. You can see we've been kind of bumbling along, you know, really not at a really high level. This is the C-class flare level right here. So we've been popping over C-class flares. Here's the M-class flare level right here, and you can see that big puppy back late on the, or you know, in the afternoon to the evening of the 7th. That long duration flare is where we actually got that big that big solar storm that's launched toward Earth. And you can see now that you see the X-ray flux floor. You see especially the red line. See how high it is here. See how low it is over here, past that flare. That is how that solar flux has dropped so much. I mean, it really depleted this region quite a bit and made it a lot more calm. So it's not nearly as angry as it was. So we'll have to watch to see whether or not that X-ray flux floor begins to rise again. Looks like we're getting a little bit of it now. You know, it's beginning to rise a little bit, but I seriously doubt we're going to see any more activity, any more serious activity from this region. At least nothing like the storm we've already seen launched from it. We'll have to wait for another region to come around. Okay, so let me show you, of course, here's the NASA model. And what I'll do is I'll show you both the NASA model and then the NOAA model moving like this. And then I'll freeze frame and show you the freeze frame of it so that you can see my annotated figures. Let me scoot this over. Okay. So here we go. This is Enlil. This is NOAA's, or this is NASA's prediction model. And you're looking down at the sun from the North Pole. I know you guys have heard me say that so many times. You can see that big solar storm being launched, whoosh, out like that as it comes out. But you can also see, do you see right before it, there's this pinwheel, Okay, all these pinwheel arms, these are fast solar wind streams. These are, and this is the density model, so you're not looking at the speed, you're looking at the density, meaning the wave that's in front of the fast wind. So you're seeing the compression of stuff, and this is where I'm talking about where if a CME gets caught in this, it'll squish. It'll squish up and become stronger. And that's really what you're seeing here in the NASA model, is that this big solar storm that looks like this funky little, you know, multicolored banana being shot out of the sun, that really is disrupting one of those pinwheels. Do you see that? Do you see that one pinwheel arm that is being disrupted? Yeah, those two in that sense are arriving together, and you can see it even better when you look at it here this is a cut in the north-south plane. Right at Earth, and you can see the fast solar, where the big density squish is that big red kind of slow-moving bubble, right? Let me wait till it restarts. Right there, and then you can see this faster kind of bubble kind of cut through it and catch up to it right at Earth. That's the solar storm. So this is what I'm talking about when I say on Twitter and stuff that it's going to be a 1-2 punch. We're going to be hit by that fast wind and then hit by that solar storm. And depending upon how quick the 1-2 is, that's going to dictate whether or not we have, you know, maybe a mild solar storm or maybe even as up to a G3. And I think that's what NOAA's, you know, they're very conservative. And so when they see something like this, they're going to probably err on the side of worse, just because it is very possible. So that's what we're seeing here. And I won't go into the splash, the impact footprint, but the splash you can see here on this is, it's definitely covering Earth. Earth is this little yellow dot. It's turned sideways in this, but I'll show you a picture where it's not in my annotated one. Now here is the NOAA, the official prediction model. Oh, it's moving quite quick. Top panel's density, bottom panel's velocity. So this top panel is the same as what you saw in the NASA version, okay? Bottom panel actually shows the speed, right? So they look slightly different. But you can see, again, we're staring down at the Earth from the North Pole. You can see that launched, and you can see that pinwheel arm that's coming out at Earth, okay? Now, if we go to the time series over here, let me put my hand in the right place. This time series, I'm going to stand on this side so you can see it. I can see what I'm doing here. This big lump in front, okay, that hits right at the beginning of the 9th, this is supposed to be the density enhancement, the squish from that solar wind stream, okay? NOAA says the solar wind stream is going to hit first, okay? Then it kind of dies back down a little bit, and then you get this second little tinier squish, right? That's the solar storm, okay? So when you see these two humps, that's what you're looking at. You're looking at the first one is due to the basically fast wind slamming into slow wind ahead of it, and just like in a lake or something, as a boat plows through the water, you get that steepening, right? You get the wave being created, that bow wave, and that's what you're seeing here. That's what this big first density spike is. Don't believe the numbers. You're not going to get a density that's up to 50 just because of that fast wind stream. It won't be that high. And to run faster than real time has to make some assumptions, and the assumptions take it a little bit away from reality. As a matter of fact, it takes it a lot away from reality sometimes, but it's really good for timing. So down here you can actually see that fast solar wind ramp up. See the slow solar wind ahead of it here is about not even 400 kilometers a second, and then it ramps up to almost 8. So with that solar storm getting in there, depending upon where that solar storm is relative to that fast wind, it's going to be squished at just, I mean, the literally perfect place to really intensify this storm. So we could be seeing some very strong magnetic field, magnetic field components, which means if any of them are pointing southward, which likely though some part of this big solar storm will be pointed southward, we could actually get really good storming. Now, if it's spread out for a little while, then what happens is that the storm intensity goes down, but the storming will last a longer period of time. Okay, so it's kind of a trade-off, right? We're going to get real intense storm if everything kind of lines up together. We'll get a really intense storm that lasts shorter, maybe 36 hours or so, maybe 48 at most. But if it's spread out and first the fast wind hits and then the solar storm hits, then we could have lower storm levels, maybe G1 or G2, and then but then we could have storming for 72 hours or more, okay, before things finally fizzle down. Because either way, the Earth ends up ringing like a bell. So you either hit it really hard and it rings like a bell and then dies down quickly, or you hit it more slowly and it rings for longer and then it just keeps ringing and doesn't want to shut up. So, you know, either way, it depends upon, I guess, where you are. Imagine if you're at mid-latitudes, you'll want it to hit really hard so you can get a chance to get aurora down in, let's say, Colorado, right? Or up to the southern tip of Australia, let's say, or, you know, maybe even easily down to the Netherlands if you're in Europe. Whereas if you're at high latitudes, well, you just want it to last a long time. You don't want it to go too far south, right? Because then it goes over you and it disappears off the southern horizon and you're like, where'd the aurora go? This is not good. So, I mean, I always feel for everybody, because everybody always has different ideas of what they want the storms to be. And of course, if you're an amateur radio operator, you hate it all. You just want the storm to go away, unless you do auroral propagation. Okay, so this is why I talk about the two different models having a bit of a discrepancy between them. If I point in the right place, am I pointing here? Yeah, okay. So this is the NASA model, and when you're looking at the NASA model, this is the freeze frame of when the storm actually hits. And you can see the impact time is really about 6 UT, which is, my goodness, in a moment now. And so you can see that, and we're not seeing that yet in the solar wind. I've been watching the solar wind. We're not seeing the impact, so I'm not sure that the NASA model is going to bear fruit. But if it does, you're going to end up seeing this solar storm hitting right about where that pinwheel is hitting. Do you notice how the two are really close together? You can hardly separate them. As a matter of fact, when you look at the north-south cut of it over here, if I put my hands in the right place, I mean, they are literally right on top of each other. You can see the bigger bubble and then the smaller bubble together. That's the solar storm, and then that's the big bubble of the squish from what we call the stream interaction region, the SIR, if you want to call it that. And then here's the impact footprint. I've actually rotated so that it's the same view as what you would get staring at the sun, but this is at Earth's location. So you can see, yes, we will be completely hit. It's actually a very nice hit. That solar storm ring, you can see, is going to definitely hit Earth without any issue. This one should not miss us. And then if I go to NOAA's version, I'm going to stand on top of the NASA one for a second. You can see when I talk about the impact time here, so I've frozen the model here now so that it's right at where that solar storm actually hits Earth. You can see in this case that pinwheel, which is that dark like finger-like thing, that is the pinwheel arm. That's the density spike from the SIR, from the stream interaction region. That's going to be followed by the fast wind. And that solar storm is just behind it, okay? And you can see it here when you look at the north-south cut. You can see it's slightly behind that bubble, unlike the NASA version that I'm standing in front of, where the two are literally overlapping. Here, the NOAA version says it's going to come afterwards. So in this case, that's why you're seeing two distinct bubbles, two distinct squishes, so to speak, in the density here in the time series. So with the NOAA prediction, they're thinking that it's not going to happen until late on the 9th. So NASA says early on the 9th, NOAA says late on the 9th. Did I do that wrong? This is NASA? No, this is NASA. NASA says early on the 9th, NOAA says late on the 9th. And so, you know, we've got this time window, right? But hey, there's a scientist in the loop. It's always hard to get these predictions right. And if you go to the CCMC scoreboard, I'm sure you will find even more predictions. And everybody's making bets and wagers, placing wagers and stuff. Scientists have a tendency to do stuff like that. But we probably have even a wider window than this. But at least everybody is convinced that this storm will hit us and that it should be a pretty decent storm. So if I go to 5-day outlooks, and where do I stand? Do I stand on this side? No, I don't. I stand over here. So what we've got is basically, we're expecting major storm, okay? And as a matter of fact, at high latitudes, NOAA is expecting 65% chance of a major storm. But as you can see, we're going to be storming potentially from the 9th all the way through possibly the 12th before things calm down. Again, it all is going to depend upon how quickly the two this 1-2 punch happens. If they happen right on top of each other, we may calm down by the 11th. If it happens a little bit more slowly, then we could still be storming by the 12th before things begin to settle down out through the weekend. At mid-latitudes, we're only expecting, we're expecting a major storm, but just barely. As a matter of fact, I actually deviated from NOAA's predictions because NOAA had something like 5% chance of a major storm and 1% chance of a major storm. And I was like, what are you talking about? How can it be how can it be like a 5% chance of a major storm when you're expecting a major storm? So I was just like, I'm going to deviate and just say that likely we have, by the 10th, we probably have at least a 15% chance of a major storm at mid-latitudes, okay? And it probably is even higher than that, but I'm trying to be a little bit conservative. I definitely think we'll be hitting at least a G1 level. I'm not sure how long it will last. Even if the field is incorrect, there's probably part of this solar storm that's going to have some southward field in it. And just judging by the fast wind stream as well, because it's a decent strong fast wind stream, we should get a little bit of storming here. So I'm expecting something easily on the 10th, then maybe into the 11th at mid-latitudes, we might still get some minor storming. But by the 12th, at least at mid-latitudes, we should be pretty quiet. So that should settle that down, and then we get to rotate into potentially getting some new regions on the sun, which will be nice to see. And now as far as the solar flare and particle radiation storm outlook is concerned, well, we're basically back to green. Everything is in the green because it looks like our regions have pretty much exhausted themselves. We have region 2790 that's still considered a sunspot, but as we just saw, that it is pretty quiet now. That you saw even the X-ray flux is quite a bit since that large near M-class flare. This is also why we have solar flux back in the 80s. Okay, things have died down quite a bit since that region really settled down. Luckily, that only brings it back to the marginal range, and it's not too bad for radio propagation on Earth's day side. And we have that new region on the sun's far side that'll be rotating into view in about 4 days. That's what I'm labeling as new on at the latter part of the week, over the weekend. Hopefully that region will then start boosting the solar flux back again. We might even see if it has any gumption left, it might actually still be it might even be a big flare player. So we might actually even see the M-class flare levels go up. I put 5% here. Not sure if that's going to go up or not. We really need to be able to take a look at this region as it rotates into view and take a look at how complex it is magnetically to really know. And then, of course, as always, we are trying to climb out of solar minimum, but we're not there yet. So you frequent flyers, if you are flying, and this does mean air crew who fly over 800 hours annually, and if you fly at high latitudes and high altitudes, you are in the moderate range for radiation dose still due to those cosmic rays. We do have a very, very, very small radiation storm right now. The levels are just barely elevated, and it's probably because of this solar storm that we're expecting here over the next day or so, and the radiation levels will go back down. Solar storms drive shocks. These shock waves do energize particles, so we are getting a tiny little bit of elevation in the radiation storm fluxes. But you will start seeing this again. We'll start getting solar radiation storms again. We've already had one from the big M4.4 flare that we had just last week. So that radiation storm has died down, but we've got, like I said, this other one that's just a little bit of elevation. And then, but that's going to die down over the next couple, probably maybe 6 to 12 hours, at least when that solar storm arrives at Earth. And then we're just going to have to start, paying attention again, because the sun is not sending these weak little solar storms anymore. It's beginning to send the big ones again. So that does mean that you're going to start seeing radiation storms from the sun, not just cosmic rays anymore. So that's the one thing when it comes to space weather, is that, solar minimum gives you more cosmic rays but less solar activity, but when the sun starts waking up, the cosmic ray levels go down, but then the sun itself starts sending radiation storms. So radiation storms are always an issue for people who fly, and that does mean prenatal passengers. That's what I mean by PN, is prenatal passengers. So please take this into consideration when you have to fly. And I think that's it, guys. Again, thank you for joining me. I wasn't expecting. Let me go back to my sun. I wasn't expecting to make this a live event here. I will show you one thing, though. You know what? Let me just show you, just for fun, since we're here, have you guys seen in the predictive science, where are you? Hold on. Here we go. Is this the one I want to show? Or is this one? Oh yeah, let's show this one. Yeah, let's show this one. So this is the predictive science solar eclipse. What they've done is they always put out these predictions of solar eclipse. Oh, I wish it would loop. How do I make this thing loop? I'm laughing at myself. Like I said, I don't have a problem doing this for my Patreon folks, but if everybody's on YouTube watching this, it's kind of silly. So what's neat about this is that predictive science, if you go to, I think it's predsci.com, I believe. If not, just type in Predictive Science Inc. and you'll get their website. Type that in Google or your favorite search engine and you'll find them. They do, every time there's a solar eclipse, they do a big prediction because they model coronal fields, and the magnetic field, of course, helps to decide what the magnetic configuration of the sun is going to look like, and then we're able to do predictions of brightness and all that kind of stuff. So they've got a bunch of predictions up right now. They finally put out their full prediction, and I thought this was such a cute thing. This is actually not one of their formal predictions. This was their preliminary prediction. But what they had done is that they actually put what it would look like if a solar storm were launched during the eclipse. So if you are planning to watch the eclipse, or if you're planning on helping HAAMSci do their experiments, HAAMSci.org is an amateur radio organization, and they always do contests during eclipses, and they're doing another one. And I on my formal forecast that's coming up, I will actually play a clip of something that they sent me so that I can kind of share that with you. If you happen to be an amateur radio operator and you want to help do some real science with your amateur radio gear, check out HAAMSci.org, because they do have a campaign that is starting, I believe, on the 9th, and then, of course, going in and through the eclipse. And so, at any rate, if you happen to be interested in what a coronal mass ejection might look like as it's coming off the sun during a solar eclipse, here's a nice little version of it for you. And they've got, of course, other really cool movies that are just unbelievably beautiful, showing different aspects of it. That's the magnetic field. I'll play that for a second so you can actually see the magnetic field configuration, which is amazing. And then, let me see, there's one more. Is that it? Yeah, this is the rotating one. So this is their final predictions. And I wanted to show you what it looked like. What it will look like, you can see the counter down here, the CML, that right there, 149.7, is where it will look, what the sun will look like when the eclipse occurs at Earth. So this is their 3D representation of that. They're just rotating the sun through longitudes, solar longitudes. And so when it gets to the 149.7, that is what it should look like. Now, the interesting thing, of course, is that you see this up here. Whoops, let me get my hand in the right place. See this right here? This streamer, who knows, maybe it'll be a coronal mass ejection, we'll see. So we'll be able to tell when the eclipse happens. We'll have a lot more updates on there. But it'd be really neat if you actually are able to, during an eclipse, watch and see something lifting off and actually erupting during that period. Be pretty cool, huh? Anyway. Okay, guys, this is it. And again, I see a bunch of comments. I'm sorry I wasn't able to catch your comments and answer them. But this forecast is kind of a surprise. I was just expecting to show this for everyone on Patreon. But if you ever want to know what Patreon's like and what my patrons get when they join my community, these are the types of things that they get. And I do this kind of stuff a lot more often than I do it on YouTube. So maybe you could check it out. Okay? Anyway, take care.